Guys, today we're going to learn about the second derivative test. The second derivative test says the following. Let f be a function such that the second derivative of f exists on an open interval containing c. If f prime of c is equal to 0 and f double prime of c is greater than 0, then we can say that f of c is going to be a relative minimum of the function f. Similarly, we have that if f prime of c is equal to 0 and f double prime evaluated at c is less than 0, then f of c is going to be a relative maximum of the function f. So let's look at this example. If we want to use the second derivative test, if possible, to find the relative extrema of the function f of x is equal to negative 3x power 5 plus 5x power 3, we need to justify our answer. So the first thing that you are going to do, since we need to use the second derivative test, is going to be find the first derivative. The first derivative of that function is going to be negative 15x power 4 plus 15x power 2. You can simplify this, and in addition to that, you can also see that I want my critical numbers, right? So I have that this is my common factor, then you have that it's x squared minus 1, and if you equalize this to 0, you can have your critical numbers that are going to be x equals 0 and plus minus 1, okay, are going to be your critical numbers over here, okay, critical numbers, okay. But in addition to the critical numbers, I also want the second derivative, because actually I'm applying the second derivative test. So take the derivative of the derivative, meaning we're going to take the derivative of the situation. You have that that's going to be a negative 60 x power 3 plus 30x. And you can factor that as negative 30x. So you do have that it's going to be 2x squared minus 1, okay? So evaluating that would be simpler, okay? So now let's do the second derivative test. To do the second derivative test, I need to take my critical numbers and evaluate the second derivative. So the first one that I'm going to evaluate is f double prime of negative 1. F double prime of negative 1, when we plug negative 1 here, you have that this is 30 times 1, that's going to be equal to 30. So this one, you are all happy, you are like, okay, so this one is greater than 0, then by the second derivative test, you do know that this is going to be a relative minimum there, okay? So everything is basically unicorns and rainbows here so far. But then you're like double derivative at 0, okay? So you evaluate here, and you get the 0, so this one, the test fails, okay? So here we cannot conclude, okay, so we need to use first derivative test, okay? We have no choice but to use something else, okay? So what are you going to use? My recommendation here is, since you have several intervals, I would only look in the first derivative test for the ones that you have the 0, meaning from negative 1 to 0 and 0 to 1. Okay, so and this one we're using the first derivative. Good thing that we have it here handy. Okay, so pick a number. I would pick negative 1/2. If you pick negative 1/2 here, this is going to be positive, negative, negative, and this is going to be positive, negative, negative, and negative. That's positive, and the same thing would happen here. So positive and positive. You do know that here by first derivative test, this is neither. But please note that my conclusion is based on the first derivative test. Okay, I'm going to put here first derivative test, so you remember when we make the conclusions, okay? I haven't justified my answer, okay? So then we have f double prime of 1, and that one, when I plug it here, I have that it's negative 30 times 1, so that's going to be negative 30, which is less than 0, so you can see that this is a relative maximum by the second derivative test, okay? So now we can conclude, okay? So by the second derivative test, okay, what do you know? Well, we know that x equals negative 1 is a relative minimum, okay, of the function f, okay. Similarly, Similarly, you have that x equals 1, okay, is a relative max of f, okay. Now, what are you going to do with the other piece? Let me grab another piece of paper, okay, so we can put it here, okay. What we can do for this one is by first derivative test. The first derivative test tells you that f prime does not, this is parentheses, does not change signs, okay, at x equals 0, okay. X equals 0 is neither a maximum, a relative max, nor relative min of the function f, okay, and that's pretty much it. But please note that for the 0, I made my conclusion based on the first derivative test and not the second derivative test, okay. So remember, this is the first derivative test, this is the second, okay. So let's move on to the next example that we have over here. Okay, so the next example that we have over there, we suppose that the function f has a continuous second derivative for all the x's, and that f of 3 is going to be equal to -4, f prime of 3 is 1, f double prime of 3 is -2. Let g a function whose derivative is given by g prime is equal to, and you have the x squared minus 9, and all of this times 2f of x plus 5f prime of x for all the x's. They ask you, hey, does g have a local max or local min at x equals 3? And we need to justify our answer. So you're like, okay, so they are asking about this famous 3. So what's the deal with that 3? Okay. So first and foremost, you need to make sure that this is a critical number. A critical number of g, okay, because they are asking you about g, that's also something that you need to realize. I need to make sure that g prime of 3 is equal to 0 or undefined. Is that true? I have g prime, okay, so I can plug the 3. Immediately as you plug it, boom, this is 0. So I'm very happy because I can conclude that x equals 3 is actually a critical number. Okay, so I'm here on the right track. I'm all happy. Okay, critical number of g, in case you are wondering. Okay, I'm like, okay, so let's apply the first derivative, right? And you're like, okay, so let me try to use the first derivative here. I'm like, okay, negative infinity to 3, 3 to infinity, and then I select, and I'm going to evaluate my first derivative, right? So g prime. So you are like, I'm going to apply the 2, okay? So you plug 2 here, okay, this is okay, but then do you have f of 2? Do you have f prime of 2? Well, the problem is not giving you enough information, so are you going to apply the first derivative? In this situation, that's useless. So we have no choice but to use the second derivative, okay? And the second derivative of this situation, we can compute it via the product rule. So you have that the first one times the derivative of the second chunk, which you know that it's going to be 2f prime of x plus 5f double prime of x, and then plus the second chunk, which is this one, okay, times the derivative of the first one. What's the derivative of this one? Is just 2x, okay? So you have all this equation, okay, as your derivative, but this is x. We want it evaluated at 3, okay, to apply the second derivative test. So when you apply the 3, all of this goes to 0. So I'm just going to put the 0 to remind you that I already evaluate that situation, okay, because this is 0, so, and it's multiplying. Then you have the 2 times f of 3 plus 5f prime of 3, close it, times 2 times 3. Okay, so what do you have here? Well, you have that 0 that goes away, so parentheses 2. What's f of 3? F of 3 is -4. Should plug it there. Plus 5. What's f prime of 3? F prime of 3 is 1. Okay, so plug it here. Close it. Then you have that 2 times 3 is 6. Okay, so you have that this is going to be equal to -8 plus 5 times 6, which you know that it's -3 times 6, which is -18. Therefore, f double prime of 3 is -18, which you know that it's what? it's less than 0. Okay, so what can you conclude here? You can conclude since f double prime of 3 is less than 0, okay, G has a relative, it would be a maximum here. G has a relative maximum at x equals 3, and that's it. Well, I hope that you find this video helpful. Bye!